this is a video for Math 2-3, Unit 3 Coordinate Geometry. This is Part 1, Basic Side Length. We're looking at the figure from the homework, where this is the x-axis right here, and we've got what looks to be a rectangle with vertices A, B, C, and D. Notice they go around clockwise like that, A, B, C, D, not crisscross. So the first one is the length of segment AB. AB is the horizontal line across the top. The work I do here will be just like the work for the bottom one, but I'm only going to do the top. I leave it to you to do the bottom one. We're looking at the distance formula for the length of a line segment. The distance between 2 points is the length of the side that connects the 2 points. And the distance formula is the difference in the x values squared plus the difference in the y values squared. I'll just make my square root a little bigger there. Now we just need to plug some numbers into it. The numbers come from the coordinates. We're going to make point A, point 1, so the x1 value is the 2 from the A, and the y1 value is the 9 from point A. Just plug those in. Square root of 10 minus 2 squared plus the square root of 9 minus 9 squared gives us the length of that side. Since this is a horizontal line segment, we should be able to see here that 9 minus 9, the difference in the y values, is 0. So 9 minus 9 is 0. 0 squared, of course, is 0. And anything added to 0 is just itself. In other words, the y values just cancel out. So we're left with the square root of 10 minus 2, which is 8, squared. One way to look at this is that anything squared and then square rooted just gets you back where you started, because squaring and square rooting are opposite operations. But I'm going to do it out just for the sake of completeness here. So this is the square root of 64, which of course is 8. In other words, the square and the square root undid each other, leaving us just with the 8. And the length of segment AB across the top here is 8. Similar calculations will give you the bottom of the rectangle. Length of segment BC, again, here is the distance formula. And the distance formula is the length of the side that we're looking at. This time we're looking at BC, the vertical line segment on the right-hand side. Plugging in all the x and y coordinates, we get 10 minus 10 squared plus 9 minus negative 6 squared. Subtracting a negative, I hope you remember, is the same as adding positive. In other words, subtracting a negative, the negatives cancel. And over here, 10 minus 10, again, is 0. So this part of the distance formula just goes away. So this equals the square root of 15 squared. And that gives us square root of 225. which of course the square and the square root cancel each other out, leaving us just with 15. So the length of the vertical side here is 15. I leave it to you to do similar calculations to find the length of this vertical side. The length of segment AC, now we're looking at the diagonal line segment, goes from the upper left to the bottom right. Distance formula again. I'm not going to write out the whole symbolic form of the distance formula, I'm just going to plug in the numbers. Point C is going to be my point 2 and point A is point 1. So we've got the difference in the x's is 10 minus 2. Hey, that looks familiar. And then we've got the difference in the y's. A little bit different this time because this time I'm using C, which has a y coordinate of -6, as the point 2. So we've got -6 minus 9 all squared. That's going to put a little different spin on this. 10 minus 2, of course, is 8, so this is 8 squared. But then over here we've got -6 minus 9, which is actually -15 squared. I want to point out that a negative squared is the same as saying negative times a negative. So -15 times -15 has to be positive 225. If you leave out the parentheses and do that on your calculator, you'll end up with -225, which is not right. It has to be positive 225 because it's a negative times a negative. Be careful of that. So this turns out to be the square root of 8 squared plus 225. I should have just made that 64 right there. 8 squared is 64. So this equals square root of 289, and that equals 17. So the length of the diagonal side, going from A to C, is 17. So looking at the information that we have here, we found the length of AB across the top was 8. The length of segment BC down the right hand side was 15. And the length of segment AC, the diagonal, was 17. And that's the end of this part of the video. The next one will be on slopes.